One of the first things you will encounter when working with WPF is Xaml. Xaml is short for Extensible Application Markup Language, allegedly. I suspect it was, like most acronyms, reverse engineered. You look at the list of pronounceable four-letter acronyms that don't already mean something, and then try to think of something it might stand for that roughly describes what you're doing. Anyway, Xaml is not only the most widely known feature of WPF, it's also one of the most misunderstood. By and large, if people know anything about WPF, they've heard of Xaml, but here are two less well-known Xaml facts. First, WPF doesn't need Xaml. Second, Xaml doesn't need WPF. They are, in fact, separable pieces of technology. To understand how that can be, let's look at some Xaml. On the left here, we have some simple Xaml describing a button. It's fairly straightforward. We have attributes defining characteristics such as the font and the color, and it also has some content. Let's look at it in XAMLpad to see these in action. There you can see the button, and you can also see that if I change the content of the element, then the text inside the button changes. By the way, if you're wondering what this underscore at the beginning is for, that signifies where the accelerator underline should appear. Now, as usual with Windows, it hasn't actually shown up by default. You have to hold down the Alt key before these accelerators will appear. If I hold down Alt, then you can see the underscore appears, and that means I can click the button by pressing Alt-C. The reason they use an underscore, by the way, rather than the more traditional ampersand that previous Windows UI technologies have used, is because that doesn't work so well in XML. If I stick an ampersand in there, the XML parser chokes because ampersand is an escape for entities. And if I want an actual ampersand, I have to type ampersand AMP semicolon to represent the ampersand entity. And that would get very tedious very quickly, so they decided to move over to using an underscore. Other than that, the content's fairly straightforward, and I can change other things as well. So if I make the font bigger, it gets a lot bigger. If I change the foreground color, that also works as expected. So as you can see, changing the attributes changes the appearance on screen directly. So there seems to be a direct connection between XAML and the screen. So how can it be that XAML isn't tightly tied to WPF? Well, XAML is really nothing more than a language for building .NET objects. On the right-hand side here, we have C# code that has exactly the same effect as the XAML on the left. In the XAML, this use of a button element signifies that I'd like to create a new button object. And this x:\name attribute indicates the name I'd like to use when referring to this button. The font size attribute corresponds to the font size property in code, and likewise the font family attribute corresponds to the font family property in code. And the content of the button element just corresponds to yet another property, content in this case. And that's pretty much all there is to XAML. Elements correspond to objects, while attributes and content correspond to properties. Now there's a whole load of details, such as how did XAML know that font size is a numeric value, whereas foreground has to be a brush? The answer, by the way, is something you might guess if you're familiar with how the property grid in Visual Studio works. XAML is simply using a feature that has been built into .NET since version 1. It uses the type converter infrastructure to map from strings in the XAML to property values at runtime. And there are also details like how it knows what to do with the content, both in simple cases like this button, but also in more complex cases like a list box where more than one child can be added. There are a lot of rules, but they're not hugely interesting, so I won't enumerate them here. The single most important thing to grasp about XAML is that it creates objects and sets properties. An upshot of this is that anything you can do in XAML, you can do in code. And you should think carefully about which to use. People new to XAML often go through a phase that I call the XAML happy phase, where they try to do everything in XAML, whether it makes sense or not. Because despite its simplicity, XAML turns out to be a surprisingly powerful way to drive WPF, so it's easy to fall into the trap of trying to do everything in it. People get this idea that XAML is somehow more declarative, and that this somehow makes it better. As we'll see later, declarative is more about style than it is about a specific choice of language. And the bottom line is, you have several tools, and you should choose the one that works best for each task. XAML is great, but it's not always the best way to do things. So that's what I mean when I say WPF doesn't need XAML. There's nothing XAML does that you couldn't do with code. But what about the converse? I also said Xaml doesn't need WPF. Well, that much should now be clear. If Xaml is just a language for stringing objects together, it doesn't really need to care what those objects are. Xaml just uses some simple rules based on XML namespaces to work out which .NET type you want for each element. And although it's not visible on this slide, that button element will need to have a default XML namespace in scope for it to make sense. There's a namespace for all the WPF elements that you'll use when writing Xaml for WPF. And there are other namespaces. There's a namespace for Silverlight, for example, which uses the same XAML language but with different objects. And there's another namespace for Windows Workflow Foundation. That uses XAML for describing workflows, which is a world away from UI construction. And of course, you can introduce XML namespaces to represent your own custom types as well. So XAML is happy to build any old object. You can even use it to build, say, Windows Forms user interfaces. Although if you try that, you'll rapidly discover that not all APIs are equally easy to control from XAML. Constructing a Windows Forms UI in XAML feels much less elegant than building WPF in XAML. And this is because WPF was designed with XAML in mind. It doesn't need XAML, but it goes out of its way to be XAML friendly. For every feature in WPF, Microsoft spent a long time considering how that feature would work from XAML, and worked hard to come up with an API that works equally well from both code and XAML. So XAML is optional, but despite this, it is at the heart of WPF's design. And remember, the goal with XAML is to enable visual designers to create user interface elements directly. So WPF aims to make it possible to control all visual aspects of the user interface from markup.